Hello, today we'll be learning about Python lists. So lists are one of four built-in data types in Python used to store collections of data. The other three are tuples, sets, and dictionaries, all with different qualities and usages. But lists will be the first thing they'll be learning about today. So lists, they look pretty similar to a variable, how you'd set it. So here's the name of the list, and then here is the content of the list. So we can separate it with square brackets, but then we have data inside, and each item separated by a comma is called an item. These are list items. And an interesting quirk of a list, which separates from the other data types I mentioned earlier, is that lists are ordered. So apple is the first item, banana is the second item, cherry is the third item. This is important because when we use lists, lists allow us to, let's say I wanted to have the first value of a list, then I could get that because the list is ordered, so it's connected. Another important part of a list is that lists are changeable. That's not true of all data types. So if I was to set a list to equal something at the start of my program, I could change it in the middle and the computer would still be happy. And another quirk of list is that you can have duplicates. So I could have apple twice in this list. And again, computer is still happy. And that's also partially because the list items are ordered. There's a few data types that don't have any ordering, so even though they might be written down here as ordered, the computer doesn't organize them as ordered, it's random. But then since everything has a kind of internal ID number that the computer connects it to, first, second, third, fourth, then we can have duplicates, and the computer can still be happy. Now let's look at some list functions. A really simple one is length, which is a shortening of length. So we can have length returns the number of items in a container, which is just the length of the list, and my list. So we can put that there, and let's print it. Run 4. That's right. 1, 2, 3, 4. We have 4 items in our list. That's good. Now this is also a good time to mention that the data type within the list, what data types the items are, doesn't matter. So these are all strings, right? But I can have a string and a boolean, or integer, or float, and the computer would still be happy. And also it can just print the list by itself without having a list, and then you just have the contents of the list. And another quick function for lists is the function type. Now this isn't exclusive to lists, but type is just a function that returns the value of the object inside it, the data type. So if we wanted to know what the data type of my list is, which I really can't tell by looking at the name, it's a list. Now that's very useful. Thank you, computer. And this might come in handy when you're given unknown variables and want to figure out what they are within the program, but then for now, it's a list. Yay, the type is a list. And also, you don't have to make a list with brackets like this. You can also have a list like with the list constructor. So just have list. Make sure you have double quotes, so I hear that that's important. And item 1. Cool item. Or true. Or 4. Yeah, so this would also make an item print cool list. and we have our list printed. Yeah, I can make it like this or this. It's really your choice. But I'll say that I see this a lot more often within code. We both do the same thing, so it is entirely up to your preference. So now let's talk about how we can access the items within a list. Now, I did mention this earlier about how you can get the item within the list, right? So let's try that out. Print my list with brackets, not parentheses that you're usually used to. Let's print first item. Let's print item index 1. Let's see what happens. What do you guys think will print? True. And I'm assuming that a fair number of you would have expected apple to have printed instead. And that's completely natural. Because when humans count, we start counting from 1, right? 1, 2, 3, 4. But for computers, that's not true. This makes sense if once you learn more about computer theory, but computers start counting at 0. Computers count 0, 1, 2, 3. So if I wanted to print out apple, then I'd have to print out my list 0. So I get apple now, right? So a quick rule of thumb is that whenever you want to print something, you take human number and then you just subtract it by 1. So let's say I wanted to print 5. That would be the third number, right? But by computer logic, it'd be subtract 1, the second index. So 5, right? There you go. And there's also something called negative indexing, where we can, well, let's say I had a really long list, or just for whatever reason, I wanted to print the last, or the end values of a list. Then I could have -1, and I'd have here. So you can kind of think of here the first item as 0, and this as moving forward, and that this as moving backwards. So I could have -2, and that would print 5. Like 1, 2, -1, 2. And you can also print a range of numbers. So let's say I wanted to print from, let's say, apple to 5. That would be 0, 1, 2, right? Let's print 0, 2. But wait, we only printed 2. Now, that's because whenever we're printing from a range, the first is inclusive, but the second number we're ignoring. So it only counts to the one before 2. So again, this is confusing, but you just have to get used to it. That's what I'll say. So if I wanted to print up to 5, then I'd have to actually print up to 3. Yeah, get used to it with practice. And now we can also have a if function. So like within an if loop, let's say I want to say if apple in my list, we have function print apple is in the list, and then else print apple is not in the list. Apple is in the list, right? So if apple is in the list. Yeah, so again, really simple if statement you can do. Now let's see how we can change the items within a list. So let's say, like I mentioned earlier, right, lists are changeable, so we can change what is in the list. So, okay, my list, we can just set variable right here. Like change a variable, right? So let's change the first entry of entry index number 1, which is actually true, to equal how. Now let's print my list. See, now we have how within the list. That's nice. And I told you about the range earlier, we can also change a range of values. I should probably add a bit more for demonstration. Demo 5, another 5. Okay, how many variables? Let's try changing from 1 to just 1 to 2. Just change it to how and hey. And again, we have to add buckets, the list of buckets, and the list with paint. So you can also edit like this, but then again, with every value you add, you have to change. It's kind of like a segment. You're switching out the segments of a list, and you're putting in the new segment. And it's also possible to just replace everything in the range of the list with the one variable if you're giving 1. So let's try changing from 5 instead. I should have added the commas. Yeah, so we can see that it's basically just cutting out everything from 1 to 5 and replacing it with this here, which is a useful tool. And you don't always have to cut out. You could also use insert. So let's use my list, and we're editing my list. So insert function can use insert. And there's two, this shows us, there's 2 things that we need. First, we need the integer of the index that we're going to insert into, and then the item that we're going to have. So let's insert something at index 3. Let's insert, this is inserted. Now let's see what happens to my list. Yep, see? So now we have that. So normally 0, 1, 2, 3, right? So after 3, we insert this is an extra. Yeah. And you don't always have to insert. So let's say you just want to add something to the end, which happens pretty often. You don't have to specify what position it is. You can just have a different function or append. Append just means add, right? At the end. So this is, let's see what happens to the list. Yeah. Now at the end, the appended is added. Yes, useful. And there's also another list function that we can do called append. So here, this requires more than one list to do, because extending is, adding 2 things together. So let's extend my list to coolest. So my list dot extend cool list and print my list. See, so this is extending the contents of coolest onto my list. So you can think of it as append, but instead of just one thing, you're appending a complete whole other list. So my list is added, yes. And to let you know, coolest, the contents don't change. Coolest is still coolest, it's just that you're copying contents into, yes, so see, coolest is still coolest, but now my list has these two added to it. Nice. And also, extend doesn't even have to add lists. Extend can add anything. You can just use it as a replacement for append, except that with extend you can add more than just one. So append adds generally only one, extend can add multiple. And if you can add, you can also remove. Probably the coolest for demonstration purposes. So my list dot remove we can also use. And you can, let's say you have a list, but you want like a list with every word in a story that you wrote, and you want to figure out what the most words that are written are. You wouldn't want like articles like the or a in the list, right? So to get like the juicy meaningful word, you could remove. So this simply removes all occurrences of a word. So let's try removing cool from my list. And I print it too so I can actually see it. Apple Crew 5, no cool. See, so what this remove does is that it removes the first instance of the specified item. So you can see that cool is removed here since it's the first one, but the second cool isn't removed. And pop can remove something from an index. So pop is like remove, except you remove connected to the order of something, the index, instead of the connected value. So let's remove the fifth item, which would be 0, 1, 2, 3, 4, 5. So demo should be gone. Yes, and there is no demo. That's good. That's how lists work. And also you can just use pop to remove, just list. Yeah, so pop just takes out cool too. It's kind of like reverse append. Okay, and you can also use del kind of command to remove the list entirely. Kind of sad. Wait, my list is not defined. Here. Yeah. So yeah, just lots of different ways to change your lists. And yeah, lists are dynamic. If you ever want to choose between using a list or a tuple, just generally use lists, unless you are absolutely sure that you're never going to change anything within it. Because lists change, tuples don't. And because tuples don't change, they do use less computer resources, unless you're really trying to optimize your program that's not like trying to do like high level coding, it's not really necessary. But those tuples are still nice to know about. And also clear the contents of a list by just doing my list.clear. And it doesn't delete my list, so my list still exists, but it clears everything within it. Yeah, so print my list, nothing shows up in my list. And you can also loop your list in for loops. So for x in my list, and x X can be anything. X is just an example. Let's try print X, because X is each entry. So it's saying for each entry X in my list, print X. So this will print apple, true, 5, cool, and almond, cool. Oh, I'll get rid of clear. Okay, so it prints everything here for us without this whatever here. So if you ever want to have a list of things that you all want to run the same program on, you could try using this kind of thing. And you can also loop through the index numbers if you want to use the numbers. Okay, let's say for X in my list, well, range my list, one my list. Again, range is how long something is, and length, I was used earlier, gives how long it is. So let's print X. So I want to demonstrate, so print number X and white space between them. Period. Now it converts into string. Converts to string. Okay. Because we want string. Can't get boolean string. Let's get rid of the boolean. I'm having a little issues, but that's with print and not list. Okay. Well, let's just have everything as print. Type compatibility. Number 1, 0. Yeah, so you can see that if I ever want to have a function where the index is important, I would have to use X like this. Yes. And you can also have, a while loop, while X is less than, well, the length of this list. And you can have print, but, always make sure to increase X by 1. Or it doesn't have to be 1, you can have, let's print by 2. Then, yeah, just as long as it's less than the list. So another can use X with not just lists, but any other data type. The for X item in data type. Yes. Now we can also have something called a condition. And a condition is kind of like a filter within a list that only accepts items that are true. So new what's the condition? Let's use coolest for this. Rating. X for X in my list if X is not equal. So this is basically doing it's running a for loop within this line right here. So it's basically making coolest will become everything inside my list that's not apple. So let's go coolest. Let's see what happens to coolest. So cool list. Cool, well, hey, cool. So we basically take out everything that's not apple, right? If X, which is each item in the list, so it goes for X, so we go through every item within the list, and we put it into cool list if it's not apple. Let's try cool instead, which is ironic, since cool list. Apple would done away since we got rid of both cools. Yes. And you don't have to even have this if statement else. You could just have x for x in my list. And that would just make coolest into a copy of my list. But I'm not sure why you do that when you could just have my list instead. And you'd have exactly the same thing. You'd accomplish exactly the same thing. And yeah, you can also do a bunch of different things with this internal conditional. You could have like x for range, like we used range in the earlier. For x in range 4. For x in range 10. Sorry about that syntax error. Yeah. So this would make x into all the numbers from 0 to 3, and you wouldn't have to count like all of them and just type them manually, right? And now for 4, that might seem a bit unnecessary, but let's say we wanted a 2,000 character long list with every number from 0 to 1999. Now, that would take a really long time to type up, right? But then the computer will do this all for us. Now, this is a bit big, so the computer might take a while to load it, but see, oh, actually not that fast. See, huge list. And I am not wanting to type that out. You can also have an expression within the list. So an expression is the current item in the iteration, but again, it's also the outcome, which you can use to manipulate so it ends up looking like the new list. So I could have, so within coolest, I could have x upper 4x in my list. And yeah, this converts everything to uppercase. Because, I mean, this does assume that everything within x is a string. Everything within y is a string, right? For each x, convert it to uppercase. So you can have, like, all the internal functions that you want run inside lists. And, yeah, this is, like, more getting into string stuff, but I hope you understand that it's iterations. You can create lists through iteration, like this, instead of having to write like for x in my list. And then if this is more pseudocode, but if x is a string, then add to cool list. You don't want to type all that out, right? You can just have all this instead. Then change to uppercase. You don't have to do that. This one line does it all for you. So a lot of coding is learning how to code efficiently. And now let's talk about sorting lists. So yeah, the default list is that list sort. You can just sort a list by having you running a function on it. My list, and since list is list, right? Of course, a list function sort. Then we can print my list. Let's see what happens. Apple cool demo. Hey, so it's been put into alphabetical order. So by default, sort puts everything in alphabetical order. Let's see what it does with digits. Nope. If compatibility error, it has to be all strings for sort to work. Then just try all numbers. Now, if we do it like this, then we'll have it sorted in numerical order, right? So the list itself can be sorted into and have items of all different data types, but the things inside it, if you want to sort it, sorts only accepts the same data type for everything. So yeah, be conscious of that. And if you want to sort like the reverse of what you'd usually expect, you could have reverse equals true. So this would instead of from least to greatest, we'd be sorting from greatest to least. And that's also the same for our original alphabetical. Reverse, oh, sorry, that goes true. And we'd have sorted in reverse alphabetical order. And all of these do come in handy when you're doing computer problems. You can also have a lot more customization within your search function. So yeah, so you can have like C, like T, like reverse, spool, all that whatever. Interesting one is so let's create a quick function. Yes, so this function now that we're going to provide us with uses this function, so f my fun, and again note function takes argument as a number, return the absolute value, this is the math function, of that number minus 50. Yes. So first, but key equals my func. So this will run my function onto everything in my list, and then it will sort my list by that. Yes, so yeah, so this is as it's sorted by what they would be in my function. And like on top of that, you can also have reverse equals true, like a lot of customization. Python's nice in that way. Yeah, so now we have it sorted in the opposite. And you can see it's not in numerical order, it's in my function order. So it'd be the greatest after it's been subtracted by 50 and found its absolute value. And also let's go back to alphabetical. By default, sort is case sensitive by default. So you have uppercase first, then lowercase prioritize. But you can also sort it so that it's case insensitive. So you can have the key, so again which function that you're going to use. So string lower. So and this is just using within string library, convert everything to lowercase and then treat it as if everything inside here is lowercase anyways. So then even though demo is still uppercase as it is here, in the sorting order, the capitalization is irrelevant. And, instead of having, reverse equals true like I mentioned earlier, you can just have reverse, which is reverse sort. If the computer wants to work. Yeah. And then you can also copy lists into each other. So coolest, let's see, let's just say I wanted coolest to equal everything in my list. I could have my list dot copy, and then my list equals this, but cool list equals the exact same thing because we just copied it. And lots of different ways to just copy a list. You can have coolest. You can also have just my list like this here. And you can also join lists. So so now we have two different full lists again. So if you want to join lists, you can just have extra cool list. You can just have if extra cool list equals my list plus cool list. and they're the same data type, technically, so you can add them, right? And then extra cool list will just be everything in my list added on top, added to with coolest appended at the end. Cool list. And if you've been catching on so far, a lot of the stuff I'm doing is extra cool list. It's just really repetitive. I'm just doing the same thing over and over again. And yeah, that's true. I mean, computer science has a lot of different ways to do things, and that just helps you be creative, you know? Different artists use different brushes, right? So you can have your own style of coding and your own preferences. You know, you can also, just if you want to make extra coolest, you can make extra coolest right here. You can run a loop. So for X in my list, can reflects in coolest because we're adding everything in coolest into my just my list dot append X because we're appending X in coolest, which X is variable, so it's cycling through. Then just add it to append, and then we can just print my list, and it will be the same because we've added high and low to the list. Yeah, and that's it. Thank you. And yeah, I'm like, I know that was really long and grueling, but hey, there's lots of different ways to make fun things with lists. Please, well, goodbye.